everyone, welcome back to Alkaline Hydroxide 784, and today is the third episode of the mathematics series. Unfortunately, I do not have any creative names for it. Actually, none of them have any creative names, never mind. And this episode will be in two parts, so this is part 3.1. Yeah, this is like the first part. Because I feel like for the graphs and transformations, I feel like I should cover the graphs with the minimum, maximum point, asymptotes and all separately, and the transformation part and parametric in the second part. So yeah, so in this one I will talk about the various kinds of graphs, how to use the GC and stuff like that, or what tricks you can do with it, and tricks for finding your maximum, minimum points, as well as asymptotes. Yeah, so once again I will clarify that I'm not gonna teach you how to do it specifically, but more of give you tips on how to do it better or faster if you have troubles doing it normally, I guess. And not, I mean, you still have to do it normally, but like to help you do it basically. So well, of course, you in this topic you get to learn a bunch of different curves, I guess. Like you get to learn about a circle, ellipse, hyperbola, and the two graphs with the linear, like ax plus b or cx plus d, or even one that is an improper fraction version of it, which is ax squared plus bx plus c or dx plus e. Yeah. So if you do not know what I'm talking about, go and look at your notes. And of course, the very first thing you need to do before you even start with knowing graphs is that you need to know how to use a graphing calculator, because, well, isn't that what it's for? It's for drawing graphs. But actually, in all honesty, you do not need it for the most part. You only need it if the graph is so complicated you cannot draw it yourself. Because all of the graphs that I've just told you are pretty easy to conceptualize. I mean, most, if not all. I mean, if you know how to do it, then, or if you know all the tricks and tips, you can do it pretty quickly. So I mean, for example, you already know that for the circle, if you write it as x minus a whole thing square plus y minus b whole thing square equals to a certain square, then you know that AB is the center point of the circle, and that's squared. When you square root it, you get the radius of the circle. I don't think you need a GC for that. And for the ellipse, likewise, it's pretty simple. It's like if you want the full version of it, it's like x minus a whole thing square over a fraction and plus y minus b whole thing square over a fraction equals to another square, another number, not necessarily one, not a square, because in this case you're just fractioning everything up, and if you times it by the denominators, you will get something that is like a square number. And from there you can draw your ellipse pretty easily, because the numbers in the denominators which are being squared, like for the x and y, are like the lengths along the axis for the ellipse, and then you can just draw your ellipse and hope it doesn't look like an egg. I think that's the most hard part of it. You had to draw it without it looking like an egg. Sorry. Because an ellipse is not an egg. It is a stretched out circle, I guess. It's like an oval, but you get the point. A circle is a kind of ellipse too. It's just that instead of having a fraction, I mean, if you divided it, the fractions would be pretty similar. Yeah, the fractions would be the same. Like, for example, if your circle is x squared plus y squared equals to 25, then when you divide it by 25, you get x squared over 25 plus y squared over 25 is equal to 1. It looks exactly like the ellipse, but it's a circle. Yeah, because a circle is an ellipse, so yeah, it works. Anyway, I shouldn't talk too much about that. Let's move on to the slightly harder ones. Okay, so for the hyperbola, you have the x squared over a squared minus y squared over b squared equals to something, or vice versa. You have y squared blah 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 minus x squared blah blah blah. is too boring to tell. So instead of a plus, you have a minus. So in this case, you don't get a circle or an ellipse, you get a hyperbola, which looks like the what happens if you cut the circle into half and then flip the two halves together. Oh, actually, that makes sense. Never mind. So how do you find out the, you know, that fraction thing? Well, actually, I did write down some method for that. But I forgot to bring the paper. Maybe I should just go and quickly bring it. Okay. Um, from this piece of paper, I can tell you one thing. Okay, so there's two ways to. The first thing you need to know is which way the graph points, right? Like if does it look like an X with the gap in horizontally or the gap vertically? Yeah, horizontally or vertically. So if you the easiest way to you know actually I don't know how to easily memorize that, but if you cannot memorize it, use a GC. If your GC is not good like mine, then I mean my GC isn't very good right now. I don't know if I can use it now, but anyways, then the easiest way to remember is if the X is in front, then you have to have the thing vertically. So so that means if you look at the second term like the Y and then you put the gap along the axis. I think that's a good idea. I think you should do that. Look at the second term and then the gap is along the axis. And then after that you need to draw the two asymptotes, the X. The X like it looks like an X when you cross it. And how do you get the asymptotes without thinking too hard? When I There's one easy way to prove that this works, and what I did was, for example, if you have x squared over a squared minus y squared over b squared is equals to 1, then I'll show you the paper. I'm showing you the paper, I hope. I'll try to show you the paper. Then you will have x squared over a squared equals to 1 plus y squared over b squared. And then you imagine x going to infinity. And when that happens, since since x is going to infinity and is equal to 1 plus y, well, y squared will be square, the 1 becomes insignificant because infinity is so huge. And then you can equate x squared over a squared to y squared over b squared, and from there you can get your asymptotes. Yeah, just do that and you get what your asymptotes are. So in this case you'll get y as b over ax, and you can put the plus and the minus and you get your two asymptotes. And likewise, if you do the same thing for the y squared over a squared minus x squared over b squared, you just equate y over a equals to x over b, and you will get y equals to a over bx or negative a over bx. And yay, we're done. See, it's not that hard. If you know how to use shortcuts, it's not hard. Okay, so the next one we need to look at is that weird linear graph, which even I have troubles dealing with sometimes. But one of the first thing you can do is to see the denominator, the cx plus d, and that gives you the vertical asymptote. That's at least the one thing you can do without the GC. If you have trouble with this, then yeah, use your GC. But if you want to do this without a GC, or if your GC is like mine, then you can try like so-called factoring it out, see if that works. Like see if you can create a 1 or 2 plus something something, and from there you can use the what's it you can use something that looks like a 1 over x and then just add it, move it up or down using transformation. Oh yeah, actually it is like transformation, and which you will learn more about in the second part, so maybe I'll reference this in the second part as well. And the next thing is to take note of the actually that's pretty much it. Once you figure out those two things, you can get your vertical asymptote, and when you factor it out, that constant that you get will be your horizontal asymptote. Like for example, if it's 1 plus blah blah blah, then your horizontal asymptote will be y equals to 1. Yeah. And for the one with the square on top of the linear, then you should definitely factor it out and see what you get. You will get a linear thing plus, this thing. And in this case, it's a bit hard to draw, but at least you would at least know what the asymptote is, which is the linear thing that you get out of the square over the linear polynomial. And you know what I'm talking about, right? Okay, I think you know what I'm talking about if you're watching the visual part, because I record audio before the visual part of it, so yeah. And yeah, we covered asymptotes. What about the maximum and minimum point? Okay, so in terms of circles and ellipses and all, I think the maximum and the minimum point is very obvious. The hyperbola, you can only get a maximum and minimum point if it is the y squared over a squared minus x squared over b squared, which is pretty obvious too. And the other things, oh yeah, the other two may have maximum or minimum points, and if you want to find them, obviously see if they exist first. But sometimes if you type it in your GC, right, you may not see all of the points. There may be this hidden maximum or minimum point, and you may have to find that out either through differentiation, which is what I'll be telling you now, or you have to really zoom out your GC or zoom it in or do something and find it. So please do be careful about it. Don't just rely on your GC very easily. As you can tell from someone whose GC almost died towards the A levels, I would advise you to not rely on your GC. But at least it still worked a little bit. Yeah. Because you need it for your stats. And thank goodness it was working enough for me to use it during stats. Otherwise you have to use your scientific calculator or something for your stats, which may not end well. Okay. So, but it's actually a lot easier with the newer scientific calculators. The older ones are a bit harder to use for deriving stats stuff, but the newer ones are very easy to, figure out the stats stuff. Anyways, back to maximum minimum points. So the easiest thing you can do is differentiation, obviously. I mean, there are definitely some special cases where you don't even need to do differentiation, like x squared. You know what is the minimum point? 0, 0. Duh. But if it's a bit more complicated thing like your ax plus b or cx plus d, then you definitely need to do a maximum or minimum point. If you can tell that your graph will have a maximum or minimum point, because sometimes they don't have it based on how what the a and the b and the c and the d are, Of course, the first thing you do is to differentiate it, and it's easier to differentiate when you already factored it out, like you brought out your constant, then you just have your 1 over something, which just becomes some negative, this 1 over something squared. Yeah, and from there you can see what is the you can try to see where what is it the y equals, oh wait, maximum and minimum point is when the thing is equal to 0. I don't, if you have a constant, if you can actually very easily factor out a constant, and the resulting thing is a 1 or a 2 or some number over something, then you will not have a maximum or a minimum point. But if you cannot factor out a constant, then or if it is something like a squared function, a polynomial over a linear, then you can find a maximum or minimum point using the asymptote thingy. Yeah, you just differentiate that and you can just equate that to 0 and you get your maximum or your minimum point. And once again, I can recap how to figure out whether it is a maximum or minimum point. Of course, the easiest way is to look at what the graph looks like. I think, but that is not the most exam useful way. Sorry, exam appropriate way, because you're not showing any working. So the next thing you can do is draw a table, and you say, oh, just before this point it is this like sloping downwards, then before just after this point is sloping upwards, and you just say that, and then you get your you prove that this is a minimum point, for example, something like that. That is the first differentiation. If wait, yeah, the test. If you want to do the second derivative test, or derivative test, if you want to do the second one, then you just need to differentiate it another time, which is very useful if you don't like to draw tables and you just want to get this done quickly. But it only helps if the thing that you differentiated gives you an easy thing to differentiate. If it's still very complicated, then don't bother, just do the table, especially if you know the answer already. And then if you do the second one, you just need to say that, oh, if it's greater than 0, then it's a minimum point. If it's lesser than 0, it's a maximum point. If it's equal to 0, then you're out of luck and you need to do the first one. Or it could just be one of those inflection points which happens on x cube graphs. Yeah. So that's the basic idea of how that works. I don't think there's anything too complicated about it. As in fact, you can use maximum minimum point, asymptotes, and your general common sense. Like you can just see what happens when one of them goes to infinity or negative infinity. And if you use all of that, you can draw a graph without touching your GC at all. It is possible. You don't need your GC if your GC is almost dying, or if you lost it or something. But you may need it for stats because you cannot easily calculate the stats stuff, unfortunately. Uh, okay, so I think that marks the end of this. Of course, the things that I told can apply to other normal graphs as well. Like, it's not just for the circle, blah blah blah. Like, it's not just for those, but it can apply for other things. And in the second part, I will continue with transformation and also parametric functions, because I thought I would talk too much if I included that here. Yeah. And with that, I would like to say thank you and bye.